Hello, everyone. Yeah, let's continue with our previous session of GCP Core Infrastructure. So now we have seen Compute Engine. What is Compute Engine? What are their characteristics or the key features? What is the virtual machine? How can you create the virtual machine? What are the key features of virtual machine? What is the instance types and the customization? And how can you manage virtual machine with Compute Engine? Yeah. After that, we have started with Google Cloud Storage. Under that, we have seen the introduction to cloud storage. Yeah. After that, we have seen what is bucket and object. We also have seen their key features. Okay. Now let's continue with the next point of storage classes and lifecycle management. Okay. So in Google Cloud Storage, storage classes and lifecycle management are essential features that enable you to optimize cost, performance, and data retention policies based on your specific requirements. Okay, so let's explore each of these features in details. So in Google Cloud Storage, storage classes and the lifecycle management are the essential features which enable you to optimize the cost, performance, and data retention policy based on your specific requirements. So let's explore each of these features in detail. Okay. So the first one is storage classes. Google Cloud Storage offers several storage classes, each designed to support different use cases and access patterns while providing the various level of availability, durability, and cost. Okay. A storage class is a piece of metadata that is used by every object. The storage class set for an object affect the object's availability and pricing model. So when you create the bucket, you can specify a default storage class for the bucket. When you add object to the bucket, they inherit this storage class unless explicitly said otherwise. Okay. So Google Cloud Storage offers several storage classes, each designed to support different use cases and access patterns while providing various level of availability, durability, and the cost. So you can see here there are four different storage classes: standard storage, nearline storage, cold line storage, and archive storage. So let's see all these storage classes in detail. Let's start with the first one, standard storage class. So this is the default storage class offering high availability, low latency, and high throughput for frequently accessed data. It is suitable for a workload requiring the real-time data access and high performance storage. Okay. So the first storage class is the standard storage class, which is a default storage class, which is offering high availability, low latency, and high throughput for frequently accessed data. So if you would like to access the data most frequently, you can go ahead with the standard storage class. It is suitable for workload requiring the real-time data access and high performance storage. Okay. Next storage class is nearline storage. Nearline storage is designed for the data that is accessed less frequently with slightly lower availability compared to the standard storage. Standard storage is designed for the data that is accessed most frequently, but nearline storage is designed for the data that is accessed less frequently with slightly lower availability as compared to the standard storage. It offers lower storage costs but may have higher access and retrieval cost. Nearline storage is ideal for backups, archives, and long-term storage of infrequently accessed data. Got it? Next storage class is cold line storage. Cold line storage is intended for data that is rarely accessed with lower availability and high access cost compared to the standard and nearline storage. Okay. So cold line storage is intended for the data that is rarely accessed. So with the lower availability, but higher access cost as compared to the standard and nearline storage. Cold line storage offers the lowest storage cost among the standard storage classes and is suitable for long-term archival and compliance data. Got it. Now the fourth one storage class is the archive storage. Archive storage provides the lowest storage cost but with the longest data retrieval time and highest access cost. It is optimized for the data that is accessed very infrequently and is stored for long period, such as regularity compliance data and the historical archives. Got it. So these are the four storage classes. So standard storage is generally used. You can use standard storage for frequently accessing the data. Okay. Nearline storage. Okay. So if you would like to access the data, maybe, not frequently, let's suppose in 30 days. Okay. After every 30 days or one times in a month, then you can go ahead with the nearline storage. In a cold line storage, okay, you are going to have infrequent access. Okay. So if you would like to access the data, for example, one time in every 90 days, okay, then you can go ahead with the cold line storage. Okay. And the fourth one is archival storage. So data has least accessibility. So let's suppose if you would like to access the data one time in a whole year. So you can go ahead with the archive storage. So standard storage for frequently accessing the data, nearline storage. Okay. If you would like to access the data, for example, one time in a month. Cold line storage, suppose if you would like to access the data, update the data for every 90 days, or you can say one time in a 3 months. And archive storage, if you would like to access the data in a one time in a whole year. Got it. I hope now you understand all these storage classes and all these storage classes, okay, when it is suitable. Okay. So which storage class you can consider based on your accessing requirement. Okay, so GCP offers several storage classes, each designed to support different use cases and access patterns while providing the various levels of availability, durability, and the cost. Got it? Yeah. Now let's proceed with the next point of lifecycle management. So we have discussed about the storage class. Now let's see the lifecycle management. Lifecycle management allows you to define rules and policies to automate the management of the objects over their lifecycle, including the transitions between storage classes and deletion. Okay. So what is this transition policies? You can define the rules to automatically transition object between storage classes based on their age or last modification date. For example, you can move the objects from standard storage to nearline storage or cold line storage after a certain period to optimize the cost while ensuring data availability. Okay. So life cycle management allowing you to define the rules and the policies to automate the management of the object over their life cycle, which including transition between the storage classes and the deletion. Okay. Now, next point is expiration policies. Lifecycle management enables you to set rules to automatically delete the object after the specified duration. Okay, so using the lifecycle management, you can have the expiration policy. So lifecycle management allow the user to set the rules to automatically delete the object after a certain period, after a specified duration. And this features helps you enforce data retention policies and comply with regulatory requirement by removing obsolete or outdated data from storage. Okay. Next point about the lifecycle management is custom actions. In addition to transitions and deletion, lifecycle management support custom actions such as sending the notification or invoking cloud function when specific conditions are met. And this allows you to implement custom workflows and business logic based on the changes in your object lifecycle. So overall, storage class and lifecycle management are powerful feature of Google Cloud Storage that enable you to optimize storage costs, automate data management, and ensure compliance with data retention policies. So by using these features effectively, you can efficiently manage your data lifecycle while maximizing the value of your cloud storage infrastructure. Got it? Now let's proceed with the next point. Which storage should I use? Okay. So which storage should I use? So can you see this? There is an object, there is a block, there is a file store. Okay. Object class, what is this? For any app, store any type and any amount of data for any duration and retrieve it as often as needed. So there is a cloud storage if you would like to store the object. Then the block is there. Can you see that? Fully integrated with the compute engine and GKE, Google Kubernetes Engine. Okay. Then there is a file store. Okay, you might think what is these things? File stores, blocks, object. Yeah. You can also see here under the cloud storage, bucket objects. Then there is the use cases for each of these one. Yeah. Now let's see this one. Okay. Which storage should I use? Your use case particular requirements will determine which cloud platform storage option is best for you. So the following list of typical Google Cloud Platform storage options and use cases include the first one is object storage. For that, there is a cloud storage. Yeah, object storage, cloud storage. For a block is there and the file store is there. So let's see this one. So which storage should I use? So your use case particular requirements will determine which Google Cloud Platform storage option is best for you. So the following list of typical GCP storage options and use cases include object storage, that is in which you can use the cloud storage. So cloud storage is an object store for binary and object data, blobs, and unstructured data. Okay, cloud storage is an object store for the binary and object data, blobs, and unstructured data. You would typically use it for any app, any type of data that you need to store for any duration. You can add data to it or retrieve the data from it as often as you need. The objects stored have an ID, metadata, attributes, and the actual data. The metadata could include all sorts of things about security classification of the file, the application that can access it, and similar information. Okay. Object store use cases include applications that need to be highly available and highly durable, such as streaming videos, serving images and documents and website. A RESTful API is used to access the cloud storage, which make it simple to integrate with other programs and services. Got it? So you can see what are the use cases for object storage and cloud storage. Yeah. Got it. So what is a cloud storage? Cloud storage is an object store for binary and object data, blobs, and unstructured. Okay. And you can use it for any app, any type of data you need to store for any duration. Okay. Got it. The object store use cases include the application that need to be highly available and highly reliable, such as streaming the videos, serving images, documents, websites. Got it? Next, please, block storage. What is this? So under the block storage, persistent disk and local SSD. Persistent disk and local SSDs are block storage option. Okay. So object storage, for that there is a cloud storage. For a block storage, can you see in the image persistent disk and the local SSDs? These are the storage options. Okay. Persistent disk and local SSD are the block storage option. They are integrated with compute engine virtual machine and Kubernetes engine. With block storage, files are split into evenly sized block of data, each with its own address but with no additional information, metadata, to provide more context for what that block of data is. Block storage can be directly accessed by the operating system as mounted drive volume. Compute engine persistent disks are suitable for storing data that require low latency access, such as databases, transactional workload, and high performance computing applications. Okay, got it. Next one is file storage. Okay, so for that we have file store. Now file store as fully managed network attached storage. File store provides a cloud-based shared file system for unstructured data. It offers really low latency and provides concurrent access to tens of thousands of clients with scalable and predictable performance up to thousands of hundreds of IOPS, tens of GBs of throughput, and hundreds of TBs. You can scale capacity up and down on demand. Typical use cases of file store include high performance computing, media processing, electronic design automation, application migration, web content management, lifecycle data analytics, and more. Got it? So we have elaborated on the question, which storage should I use? For object storage, we can go ahead with the cloud storage. For a block storage, we have the option of persistent disk and local SSD. Okay, and file store, we are having the option for file store. Got it? We also have seen what are the use cases for object storage, block storage, file stores. Got it? Now let's proceed with the next point, GCP networking. Google Cloud Platform Networking provides a robust set of services and features to create, manage, and optimize network resources for your cloud-based applications. GCP Networking Services offers IP transit services in peering locations around the world. You can also create your own private connection. Google Cloud Platform Networking Services have a rich set of networking tools that allow you to design networks using APIs or Cloud Console or CLI commands for advanced use cases like configuring firewall rules. Yeah. One of the fundamental component of GCP networking is the virtual private cloud. Okay. So one of the fundamental component of GCP networking is a virtual private cloud. So let's explore what virtual private cloud is and what are its key features. So virtual private cloud is a virtual network dedicated to your GCP project. Okay, so a virtual private cloud is a virtual network dedicated to your GCP project. It provides an isolated and logically segmented environment where you can deploy and run your resources such as virtual machine instances, containers, and services with customizable networking configuration. Okay, next point, isolation. Each virtual private cloud is logically isolated from other virtual private cloud in GCP. Okay, each virtual private cloud is logically isolated from other virtual private cloud in GCP, providing network isolation and the security for your resources. It allows you to define private IP address range, subnets, and firewall rules to control traffic flow and access within the virtual private cloud. IP address management. Next point, IP address management. With virtual private cloud, you can define private IP address range for your virtual network, allowing you to segment your network into subnets and allocate IP addresses to resources within those subnets. Virtual private cloud support both IPv4 and IPv6 addressing. Okay. Next key point about virtual private cloud is subnetting. Within the virtual private cloud, you can create multiple subnets, each associated with a specific region or availability zone. Subnets allow you to partition your virtual private cloud into smaller, manageable networks and deploy resources in different geographic locations for high availability and fault tolerance. Okay. Next is firewall rules. Virtual private cloud includes a distributed firewall that allow you to define ingress and egress firewall rules to control traffic flow between resources within the virtual private cloud and between the virtual private cloud and external networks. Firewall rules are applied at the instance level and can be configured based on the IP addresses, protocols, and ports. Okay. Next point about the virtual private cloud VPC is routing. VPC virtual private cloud provides dynamic routing capabilities to route traffic between subnet within the VPC and between the VPC and other VPCs on-premises network or the internet. It supports both original and global routing, allowing you to route traffic efficiently based on the destination and origin. Got it? Now let's see what are the benefits of virtual private cloud. So we have seen what are the features and the key components for a virtual private cloud. Okay. So remember, virtual private cloud is a virtual network dedicated to your GCP project. And it is providing an isolated and logically segmented environment where you can deploy and run your resources such as virtual machine instances, containers, and the services with customizable networking and configuration. Got it? Now let's proceed with the next point. What are the benefits of virtual private cloud? The first one is security. Virtual private cloud provides network isolation and segmentation, allowing you to enforce security policies and control access to resources within your virtual network. Got it. Next benefit of virtual private cloud is scalability. Virtual private cloud scales with your business needs, allowing you to create and manage networks of any size and complexity to support your growing workload requirements. Yeah. Another benefit of virtual private cloud is flexibility. VPC offers flexible networking configuration, including custom IP address ranges, subnets, firewall rules, and routing policies to meet the unique requirement of your application and workload. Yeah. Next benefit of VPC is performance. VPC is designed for higher performance or high performance, low latency, and high throughput networking, ensuring optimal connectivity and data transfer speeds for your cloud-based application. Okay. Next benefit of VPC is cost effectiveness. By leveraging virtual private cloud, you can optimize network resources, reduce data transfer cost, and minimize egress charges, resulting in cost-effective networking solution for your cloud deployment. So in summary, virtual private cloud is a foundational component of GCP networking that provides a secure, scalable, and flexible networking environment for deploying and running your cloud-based application and services. With virtual private cloud, you can build robust and resilient network architectures to meet the evolving needs of your business. Got it? Yeah. So finally, we have covered all the topics, all the session, all the topics of our module GCP Core Infrastructure. So we have seen what is compute engine. Yeah. The key features are the important points about the compute engine. After that, we have seen what is the virtual machine. What are the features or the important point about the virtual machine? How can you create the virtual machine? How can you manage the virtual machine? What is the instance types and the customization? Yeah, after that, we started with the Google Cloud Storage. So we have seen what is mean by cloud storage. Okay. What is Google Cloud Storage? What is bucket and the object? Okay. And what are the different cloud storage classes? Yeah. What are those? Yeah, we have seen that. Cloud storage. Yeah. The first one is standard storage class. Then nearline storage class, and then cold line storage, and then the IQ storage class. Yeah, remember, these are the storage classes. Standard storage class, nearline storage class, cold line storage class, and RQ storage class. Okay, so we have elaborated on all these points. Am I right? So standard storage class generally used if you would like to access the data most frequently. Nearline storage class, when to use it? Let's suppose if you would like to access the data, suppose 30 days, one time in a 30 days. Okay. In a month, if you would like to access the data one time, so you can go ahead with the nearline storage. But in case of cold line storage, if you would like to access the data one time every 3 months, or one time in 90 days, you can go ahead with the cold line storage. And if you would like to access or update the data one time in a whole year, so you can go ahead with the archive storage. So we have elaborated on what is the standard storage, nearline storage, cold line storage, archive storage, what are their features. Okay, we also have seen that. And then we have seen what is the life cycle management. What is the role of life cycle management? After that, we have started with the GCP networking, Google Cloud Platform networking. So one of the key fundamental component of GCP networking is virtual private cloud. So we have seen what is a virtual private cloud. Yeah, we have seen that. And with that, we also have seen what are their key features. Okay. And yeah, we also have seen which storage should I use based on your use cases, based on your requirements. So for object storage, you can go ahead with the cloud storage. For block storage, there is a persistent disk and the local SSD storage option. To store the file, there is a file stores. Yeah. So we have seen that, yeah, for a block storage, persistent disk and the local SSDs are block storage options. For object storage, there is a cloud storage option. For file storage, there is a file store options. Yeah, we have seen all these points. And then under the virtual private cloud, we have seen its definition, what their components, what is their important features. And finally, we have seen what are the benefits of virtual private cloud. So I hope now you understand all these points which we have covered under the GCP core infrastructure. So in the next module or the next session, we are going to start with data storage and databases available in your Google Cloud platform. Okay, so under that, we are going to see what are the relational databases in a Google Cloud, what are the non-relational databases available or in your Google Cloud platform. Yeah, we will also see Google storage options for if you would like to handle the big data. So we are going to see what is BigQuery, data warehouse. Yeah, so we are going to see all these things. What are the relational databases in Google Cloud? What are the non-relational databases options available in Google Cloud? And if you would like to, deal with the big data, so how can you go ahead with this? Okay, and we will see the overview of BigQuery and data warehouse in our next session. So I hope you have understand all the topics we have covered under the GCP core infrastructure. Yeah. So thank you very much for attending this session. See you in our upcoming session. Thank you. Bye.